Hi dear students, welcome to a new geometry session, and now we'll be having a general revision on geometry. Let's now see the questions. The first question is asking us to choose the correct answer. Number 1, the equation of the straight line whose slope is 1 and passes through the origin is which of the following equations? As long as it passes by the origin, so this means that its y-intercept is 0, then c is 0. If you write the equation, y equals mx plus c, where m is 1 and c is 0, then the equation is y equals x. So the right answer here is choice C. Question 2. If LM is perpendicular to EO, where the coordinates of E are -1 and 2, and O has a coordinate of 0, 0, then what is the slope of LM? First of all, let's find the slope of EO. Slope of EO is y2 minus y1 over x2 minus x1. Then the slope of EO is -2. Given that LM is perpendicular to EO, then the slope of LM is the negative reciprocal of the slope of EO. So the slope of LM is positive half. Then in question 2, the choice is choice C. Question 3. If tan 3x equals square root of 3, where 3x is the measure of an acute angle, then find the measure of angle x. So if you check the special right triangles, you will see that tan what equals square root of 3? Yes, you guys are right. Tan 60 equals square root of 3. Then here, tan 3x is the same as tan 60. So 3x is equal to 60, then x equals 20. So the right answer in question 3 is choice B. In question 4, if the origin point is a center of a circle of diameter length 6 length units, then the point which belongs to the circle is what? As long as the center is at the origin, so the radius is square root of x1 squared plus y1 squared. So which of the following choices will give me the radius of 3? Why did we get the radius of 3? Because the question says the diameter is 6. So the radius is 3. Then the radius is square root of x squared plus y squared. So you're going to check which of these points, if you make a square root of the x squared plus the y squared, will give you 3. Then if you check choice C, you will see that the square root of 8 squared plus 1 squared is equal to 3, which is the length of the radius. So in question 4, the right answer is choice C. Question 5. In triangle ABC, if C is a right angle, then what's sine B? Then sine B plus cosine B is what with relation to the 1? Is it equal, greater than, less than, or equal? So if you can see it in this one, you will see that sine B plus cosine B is greater than 1. In question 6, if sine x equals half, where x is an acute angle, then sine 2x equals what? First of all, let's find angle x. If we have here, if it's given that sine x equals half, So you need to check, sine what equals half? Yes, so x equals 30. Then the question wants you to find sine 2 times 30, which is sine 60. Then you need to find sine 60, that you will see it's equal to square root 3 over 2. So in question 6, the answer is C. Question 2, part A. The question wants us to prove that the triangle whose vertices are the points y, x, and z, and their coordinates are given, is a right triangle at y. In order to show that the triangle is a right triangle, you need to find the length of each of the 3 sides, and then check the longest side squared and the other 2 sides squared plus each other. If you found that the longest side squared is greater than the sum of the other 2 sides squared, it's an obtuse triangle. If you found that the longest side squared equals the sum of the other 2 sides squared, then it's a right triangle. And if you found that the longest side squared is less than the sum of the 2 other sides squared, then it is an acute triangle. So in this question, we need to find first the length of the 3 sides. So here, yx equals, yes, we're going to use the distance formula. So it's 2 minus 0 all squared plus 4 minus 6.8 all squared. The length of yx is 2 square root of 74 over 5. Let's now find the length of yz with the same way. You will see that yz equals square root of 2 minus negative 5 all squared plus 4 minus negative 1 all squared. Then the length of yz is equal to square root of 74. With the same way again, we find the length of xz square root of 0 minus negative 5 all squared plus 6.8 minus negative 1 all squared. Then the length of xz equals square root of 2146 over 5. Let's now check xz squared, and in the other side yz squared plus yx squared. Xz squared, so xz squared is square root of 2146 over 5 all to the power of 2, and on the other side yz is root 74 all squared plus yx, which is 2 square root of 74 over 5 all squared. The xz all squared is 2146 over 25, and in the other side it's also 2146 over 25. Then these two sides are equal. Then triangle XYZ is a right triangle at Y. Question 2, part B. The question says ABC is a triangle in which AB is equal to AC, and each of them is equal to 10 centimeters long, where BC equals 12 centimeters long. And AD is a perpendicular to BC that intersects it at point D. So let's draw the triangle first. Here is the triangle, and we're going to name it triangle A, B, C. Then we're going to draw the perpendicular to BC. So this line is perpendicular to BC and it intersects it at point D. And we know from the givens that AC is 10 centimeters, AB is 10 centimeters, as long as this is an isosceles triangle, and this is a perpendicular line coming from the vertex, so BC, which is 12, is now bisected into 6 and 6. In order to prove that sine B plus cosine C equals 1.4, we need first to find the length of AD. So AD equals square root of 10 squared minus 6 squared, which is 8 centimeters. So now AD is 8 centimeters long. So let's now go and start proving. Question 1, sine B, that is opposite over hypotenuse, plus cosine C, that is adjacent over hypotenuse. If you calculate this, this is 14 over 10, which is 1.4. Question 2, how to prove that sine squared C plus cosine squared C equals 1. So here, sine C is 8 over 10 all squared, plus cosine C is 6 over 10 all squared. If you do your calculations, you will see that this is 64 over 100 plus 36 over 100, which is 100 over 100, that is equal to 1. In question 3, the question wants us to find the value of this fraction without using the calculator. So the first thing you need to do is to draw the two special right triangles in front of you in order to be able to find the exact solution. Here are the two special triangles. Let's now find the value of each part. Here's our fraction. Cosine 60 is half, so it's half squared, plus cosine 30 is square root over 3 all squared, because the question says cosine squared 30 plus tan squared 45, which is 1 squared, because tan 45 is 1, over sine 60, which is square root of 3 over 2, times tan 60, which is square root of 3, minus sine 30, which is half. If you simplify the fractions that you have, you will see that half squared is 1 over 4, plus this part squared is 3 over 4, plus 1 over 3 over 2 minus half. If you simplify the numerator, it will be 1 plus 1, and the denominator will be 1. Then the answer is 2. In the second part of question 3, the question wants us to prove that this given figure is a square. Let's first remember together what are the properties of a square. The square is a quadrilateral with 4 equal sides, and the vertices are formed by right angles. Then I need to prove that the 4 sides have equal lengths and the 4 angles are 90 degrees, or you can prove that each 2 adjacent sides are perpendicular to each other, and also each 2 opposite sides are parallel to each other. Let's now start by plotting the points on the graph. Here's the graph. Here's point A, point B, point C, and point D. The question wants us first to prove that they are vertices of a square. Let's now find the length of AB. To find the length of AB, it is square root of 2 minus negative 1 all squared plus 3 minus negative 1 all squared. Then the length of AB is equal to 5. Let's now find the length of BC with the same way. Square root of negative 1 minus 3 all squared plus negative 1 minus negative 4 all squared. Then the answer of this one for sure will be also 5. Find the length of CD with the same way, 3 minus 6 all squared plus negative 4 minus 0 all squared. Then the length of CD is also 5, where AD, its length for sure will be also 5 by making 2 minus 6 all squared plus 3 minus 0 squared. Then the result is 5. Now we proved that the four sides are equal. That's not enough. We have to find the slopes of the four sides to prove that the opposite sides are parallel, that they have the same slope, and the two intersecting sides are perpendicular to each other. So the slope of AB equals y2 minus y1 over x2 minus x1. So it's equal to 4 over 3, where the slope of CD, the opposite side to it, is 0 minus negative 4 over 6 minus 3, which is 4 over 3. Where the slopes of the other two sides, the slope of BC equals negative 4 minus negative 1 over 3 minus negative 1, that is equal to negative 3 over 4. Where the slope of AD equals 0 minus 3 over 6 minus 2, which is equal to negative 3 over 4. As you can see here, that the four sides are equal in length, the two opposite sides, they have the same slope, then they are parallel to each other, and the two intersecting sides are perpendicular to each other, where their slopes, when you multiply them, they will give you negative 1. So you can write it as, since AB is equal to BC is equal to CD is equal to AD, and since AB is parallel to CD, where BC is also parallel to AD, and also since AB is perpendicular to BC and BD is perpendicular to CD, therefore ABCD is a square. The last part of the question wants you to find the area of this square. For sure, you know that the area of the square is the side squared, so it's 5 squared, which is 25 units squared. Question 4 says, find the value of x, where x is greater than 0 and less than 90 degrees. So x is an acute angle. If sine x times sine 45 times cosine 45 times tan 60 is equal to tan squared 45 minus cosine squared 60. For sure, in this question, we're not allowed to use the calculator. So we need to have the special right triangles in front of us. Here are the two special right triangles. Let's start evaluating each of the givens. Let's start evaluating each of the trigonometric functions. Sine x times sine 45, which is 1 over root 2, times cosine 45, which is 1 over root 2, times tan 60, which is root 3, equals tan 45, that is 1 squared, minus cosine 60, which is half squared. So sine x multiplied by root 3 over 2 is equal to 1 minus 1 over 4. Then sine x equals 3 over 4 multiplied by 2 over square root of 3. Then sine x is equal to 3 over 2 root 3. If you multiply by root 3 up and down, sine x would be equal to 3 root 3 over 6, which is square root of 3 over 2. Sine what angle equals root 3 over 2? For sure it's sine 60. Then x equals 60 degrees. A straight line, its slope is half, intercepts from the positive part of x-axis a part of length 2 units. Find, the first thing, the equation of this straight line. The second thing is to find the intersection point with the y-axis. The question is saying that this line intercepts the x-axis with 2 units, then the x-intercept is 2, so the point here is 2 and 0. In order to find the equation of the line, we need to find the slope, which is here half, and the question says that this line intercepts with the x-axis a part of length 2 units, so it intersects at point 2, 0. In order to find c, which is the y-intercept, x, we replace it by 2, and y we replace it by 0. You know the equation, it says y equals mx plus c, so 0 equals half times 2 plus c, then c equals -1. So here the equation of this line is y equals half x minus 1. Part 2 of the question is asking you to find its intersection point with the y-axis. Since c is -1, then the y-intercept is -1. But the question here is asking you to find the point of intersection, then the point of intersection is 0 and -1. Question 5a. Find the equation of the straight line which passes through the 2 points 2, 3 and -3, 2. In order to find the equation of the straight line, we need first to find the slope. So m equals y2 minus y1 over x2 minus x1. The slope here equals 1 over 5. You can pick any of the 2 points and make it as xy. Let's, for example, pick this point and name it as xy. We know that the equation y equals mx plus c, we replace the y by 3, equals m times x, which is 2, plus c. Then 3 minus 2 over 5 equals c. Then c equals 13 over 5. To find the equation will be y equals 1 over 5x plus 13 over 5. Question 5b. If the points A, B, C, and D are in the coordinate plane, prove that ABCD is a rectangle, and then find the length of its diagonal. In order to prove that this figure is a rectangle, you need to prove that each two opposite sides are equal in length and each two opposite sides are parallel, where the two intersecting sides are perpendicular to each other. So let's now start by finding the length of each side. AB equals square root of 1 minus negative 1 squared plus 0 minus 4 all squared. So the length of AB is 2 square root of 5. You find the length of BC, it's equal to square root of negative 1 minus 7 all squared plus 4 minus 8 all squared, which is equal to 4 square root of 5. By the same way, you find the length of CD, which is square root of 7 minus 9 all squared plus 8 minus 4 all squared. That will be equal to 2 square root of 5, where the length of AD equals square root of 1 minus 9 all squared plus 0 minus 4 all squared, and the length of AD in this case will be 4 square root of 5. As you can see here, every two opposite sides are equal in length, as AB is equal to CD and BC is equal to AD. Let's now find the slopes of the four sides. The slope of AB equals 4 minus 0 over negative 1 minus 1, which is equal to negative 2, where the slope of BC equals 8 minus 4 over 7 minus negative 1, that is half, and the slope of CD equals 4 minus 8 over 9 minus 7, which is equal to negative 2, where the slope of AD equals 4 minus 0 over 9 minus 1, and the result is half. So, as we found, we can write as since AB is equal to CD and BC is equal to AD, and also since AB is parallel to CD as they have the same slope, where BC is parallel to AD as they also have the same slope, and also since AB is perpendicular to BC as the product of their slopes is negative 1, and CD is perpendicular to AD, then therefore ABCD is a rectangle. Let's now go and find the last part in this question, which is asking us to find the length of the diagonal. What is the length of the diagonal? The diagonal is either AC or BD. So to find the length of the diagonal, you can say that AC equals square root of 1 minus 7 squared plus 0 minus 8 squared, then the length of AC is 10 unit length. By solving this example, we came to the end of our revision. Thank you very much, dear students, and wishing you best of luck.